Hello everybody, here we are, 5.4 factoring special trinomials. This lesson we're going to focus on, there's two kind of special trinomials that we want us to learn about. The first one over here is a difference of squares, and the second special trinomial is a perfect square trinomial. So we'll learn about those two. I have the description in words, which I think can be a little bit tough, so I have some kind of diagram that goes along with it, and so I'll explain both. So here's a bit of a description of what difference of squares means. So imagine that when you cut a square from a square, this is what we're doing right here. We're cutting a square from a square. The remaining shape is the difference of two squares. So what remains is the difference. So a subtraction, subtracting one square from another. And this is difference of squares. Here, we are looking for a perfect square minus a perfect square. So in this one, we have this section right here would be v squared. So v times v, that's what we're cutting out. This big square right here would be u squared, u times u. This one would be u squared, but we've subtracted out the v squared. And what we're left with, how they get from this shape right here to this one over here, is imagine we've cut out this section, okay? And what's left, if we take this little square right here, or this rectangle right here, and we put it right there. So if now this takes up this section, and this section here would be that section. What we're left with on this side would be v, or u minus v, and this side over here would be the u plus a v. So essentially what we're looking at, we've got this is a u squared minus the v squared. And what we're looking at here is u minus v times u plus v. And that's the difference of squares. If you FOIL this out, which why not? I'll do it now. If you FOIL it out, you're actually going to end up with, we're used to when we're FOILing, ending up with a trinomial. But we're actually going to end up with a binomial, and I'll show you why. So if we have u times u, we have u squared. Then we have a u times a positive v plus vu. And then we have a v times a positive u, subtract vu, and then we have v times negative v times positive v, negative v squared. And what do we notice? We have a positive vu and a negative vu, which is going to make 0. And what we're left with is the u squared minus the v squared, or the difference of two squares. And I think that'll, hopefully make a little bit more sense when we get to the numbers. But that's our first kind of description of that. And then let's look over here. Another type of special type of trinomial is a perfect square trinomial. So in this, the first term is a perfect square. The last term is a perfect square. So this would be a perfect square. That's x times x. This last squared would be a perfect square. That's true. That's 8 times 8. Let me show that for you. This is x times x. And this middle description, I think, is the mess that's a little bit hard to understand. But the middle term is twice the product. So twice, so 2 times the square root of the first term and the square root of the third term. So we're looking for 2 times, x times 8. And so 2 times 8x. And that would be, if we distribute it inside, 16x. So that's what the middle part means. If we have, this one over here times this one over here, and 2 times that, you're going to get the middle. So let's try it again. If we had, see this, the square root of this, 9 squared is 3. 3x is the square root of that. Over here, the square root of 25 is 5. And so this middle term is going to be 2 times 3x times 5. We multiply those together, we're going to have 2 times 15x. And we distribute that inside, we get 30x. So there you go. So we're looking for perfect squares on the outsides, and that the middle is 2 times this, the square root of this, the first term, times the square root of the third term. Okay, and this one we're looking for the difference, so a perfect square minus a perfect square. Okay, a lot of description. Hopefully it'll be kind of cleared up with some of the examples. Here we're factoring each binomial, so we're looking for likely a difference of squares. Here, x squared is a perfect square. That's x times x. And here, 144 is a perfect square as well. That's 12 times 12. And the thing that you need to remember when you're doing the difference of squares is that you're going to have, an x 12 times an x 12. But one has to be positive and one has to be negative because you want to end up with it's a difference of squares. So it needs to end up being a negative 144. So let's check. We got x plus 12 and an x minus 12. Let's FOIL that and see if we got where we started. I'm going to do first outside. We're going to do inside last. So we got x times x is x squared. X times negative 12, negative 12x. 12 times positive x plus 12x. And positive 12 times negative 12, negative 144. And now you'll see we have these two like terms in the middle, but what do we notice? It's a negative 12x and a positive 12x. Those are going to cancel each other out to 0. We're left with x squared, subtract 144. So there you go, did it. This next one looks like we have two perfect squares. We got, an a times an a, and we got a 3 times a 3. So we need to have an a plus 3, and the other one has to be a minus 3. And now let's check. We got a plus 3, a minus 3, and let's FOIL it out. So we're going to do first outside, inside last, and a times a is an a squared. A times negative 3, negative 3a, positive 3 times a plus 3a, and a positive 3 times a negative 3, negative 9. These two middle terms are going to zero each other out, and we are left with a squared subtract 9. So indeed where we started. There you go. Okay, and these next ones are very likely going to be our perfect square trinomials. So we're starting off strong. We can see that the first term is a perfect square. That's x times x. And our last term, perfect square, that's 7 times 7. And is it true now that this is, is this 2 times 7x? Is that true? Yeah, I would say that it is, that's 14x. And so what we need to do here is just match these up. We've got an x plus 7 and an x plus 7. And y, so it's x plus 7 squared. That's why it's a perfect square. It's this times itself. So then let's check. Is x plus 7, if we FOIL this out, do we end up where we started? Let's do our first outside. Let's do inside last. And we get an x times x, x squared, plus x times plus 7 plus 7x. 7 times x plus 7x. And positive 7 times positive 7, a positive 49. Let's combine these like terms. They're both positive, so unlike our last ones, they're not going to zero out. They're going to be added to each other. We got x squared plus 14x plus 49. And there you go, we did it. Okay, let's do another one. Looks like we have a perfect square. We got a y times a y. We have another perfect square. We got 20 times 20. And is this, I notice this is a negative. So is this 2 times, and I'm going to add now, this should be a negative 20. Negative 20 times negative 20 still equals a positive 400. Oops, negative 20 times negative 20. So is it true that 2 times negative 20y is going to give us negative 40y? Yes, it is true. And so let's pair these two up. Looks like we're going to have a y subtract 20 and a y subtract 20, which is, you should show this as your final answer, y subtract 20 squared. That's the perfect squareness of it, and that's a good way to show your final answer. And then let's check. If we FOIL this, are we going to end up where we started? So let's do the first and outside. Let's do inside and last. Y times y is a y squared. Y times negative 20, negative 20y. Negative 20 times y, negative 20y. And negative 20 times negative 20 is a positive 400. Let's combine our like terms. And we're left with y squared. Negative 20 plus another negative 20 is negative 40y plus 400. And there you have it. Ding, 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 we did it. Okay. So not so bad. Last, I got two more. What am I saying? Last one. So we have some numbers, a little bit more complicated, but you can see they're still perfect squares. We have 64, which is 8 times 8, and we've got an a squared. So this is 8a times 8a, or 8a squared. Here we have a 9, which is 3 times 3, and we got a b squared, which is b times b. So it looks like we got a 3b times a 3b. And is it true? We have a negative 48. So likely these got to be negatives. They're going to multiply to a negative 9, but add to a negative. So is it true that this is 2 times 8a times negative 3b? So is it true that this is 2 times, that's going to be negative 24ab? Yeah, it looks like it. 2 times negative 24 is going to give us a negative 48ab. So I think we're in the money. And now let's pair these two up. So these ones are going to be paired with these ones, and these ones with these ones. We'll end up with an 8a subtract 3b times an 8a subtract 3b, or 8a subtract 3b squared. Oh, not squared there, squared on the outside. And then let's check, is it true that 8a subtract 3b times 8a subtract 3b is going to get us to where we started? Let's check. Let's FOIL it out. Let's do the first and outside. Let's do inside and last. So we got an 8a times an 8a, that's 64a squared. 8a times negative 3b, negative 24ab. Negative 3b times 8a, negative 24ab. And a negative 3b times a negative 3b is a positive 9b squared. Let's combine those like terms in the center. We're left with 64a squared subtract 48ab plus 9b squared. And we did it, everybody. Lovely. Okay, this last one I have on, it's just kind of a little bit of reverse. I put it on there because you have a textbook question like this. In fact, I think you have this exact textbook question. So you're just kind of doing a bit of retrofitting, kind of working backwards. So looks like we're looking for a perfect square. We also have trinomial, so good indication it's not a difference of squares. And we know our last term is going to be the second term, the. All right, I got cut off. We know this part is going to be the square of that one. We know this term here, this one, the square root of this, the square root of 4 is 2. The square root of x is x, so that's going to be 2x times 2x. So we know that's the term going to be there, 2x. Seems like we kind of solved it, but what about this middle term? So we know the middle term is going to be 2 times 2x times 5. So we know it's going to be 2 times 2x times 5, 10x. So we know it's going to be 20x. 20x. And then let's check. So is it true? We have, this is our kind of, final answer. We can check that by having it 2x plus 5 times 2x plus 5 and just see if this is true. So if we do first outside, if we do inside last, we have 2x times 2x, that's 4x squared. 2x plus 5, or times 5 plus 10x. 5 times 2x plus 10x. And 5 times 5 plus 25. Combine our middle-like terms. And looks like we're going to get 4x squared plus 20x plus 25. And yes, that's what we have over there. Looks like we did it. Thank you so much. I'll let you know what textbook questions I'd like you to do.